have graded the work that you have uploaded before spring break. Okay, so you have certainly received the feedback and the points. And what I will do after this session today is I will send an Excel with all your grades, because I have made a mess on the grade center. So I didn't know how to configure that. And so it's well, of course you can see the points, but you cannot see your grades, you cannot see anything. And this is because I configured it wrongly, and then it's very complicated to do rollback and have a reasonable grade center. So before I can do that and I figured out how to get technical support and not lose my data, etc., what I will do is I will provide an Excel with all the points that you have achieved until now. I already tell everyone that there is no worries to have about. Everyone is, well, of course, there are variations because some people have do better jobs than others at some point, but in general, you won't have problems. And besides, well, we are now, you have now achieved, the maximum points that you should have achieved possibly until now is 50 points. Okay, that's the maximum. And then you are still challenging 50 points. So the third part, which we are starting today, and then the final work. And beyond that, I know that grades in Mexico are very important, and some of you have fellowships, etc. So at the very end of the semester, I will provide a very, very short questionnaire in order that you can get extra points. Okay, so as I insist always, because sometimes you get anxious about grades, etc. Until now, it's fine. And if you worry still about what can happen after this half of a milestone, do not worry, because there will be plenty of opportunities to gain points and have good grades at the end of both the lab and the regular course. So just keep working, because that's what it's important to do, so that you can get the maximum of what we're doing, and then do not worry about the rest. So for those that have connected only now, I'm saying that if you have either technical or calendar questions about the work that you have to hand in this week, please write them on Slack so that I can have a look at all the questions and I can answer for the whole group, because I think that some of you are the same questions. So instead of answering one by one, I can answer in total, and then if there are particular aspects that you want to treat in private, we can do that, right? So that's the first administration announcements. And then today we are going to start the third, we are almost done, okay? So there are 4 topics that I have proposed for both the lab and the regular course. We are starting this week and next week the third one, and then we will conclude. It will be more perspectives, etc., in the very last part of the course. So we are almost done with what has been planned for both the lab and the regular course. So I'm going to stop sharing the Blackboard, and then this is not what I'm looking for. Okay. Now you are probably having a look at my screen, and here you are. And so today we are going to start a very nice thing. You will see. So some announcements before. I will share this the whole paper in on Slack, but there is a data science hub where people share a lot of things. And since I graded your the exercise you did on statistics to complete the notebook that we have addressed, they have very nice infographics saying how to test. In fact, it's statistics of how to declare the hypothesis. Remember that you have the zero hypothesis, and then how to work with statistics in order to confirm it um, or challenge it with different techniques. So that's one thing. And then one aspect that was discussed in the exercise that we did, and all the reasoning about that notebook was about bias and variance. In fact, they observed a lot how variance was working, and they observed the possible bias that using variance could lead to in order to answer the research question, which was related to gender gap. And so these infographics represents the different possibilities of bias that can happen when we use variance as a metric. So that's one thing. And then the other thing, since I always think that you are preparing your professional life, and that you can certainly be hired in companies, etc. But another possibility is to run your own business. And so one thing that it's important that you can know is that in particular in Microsoft, there's an action, it's Microsoft for Startups, and they have keynotes, and they have discussions and material and many different interesting information for people willing to propose startups and start designing their own business. And I think the vision that they have and the kind of support that they provide for entrepreneurship is quite interesting. So again, in the slides there will be the link. This comes from LinkedIn, so if you are on LinkedIn, you can have a look at Microsoft for Startups, and there you can follow a lot of actions, activities, etc. that they organize regarding these entrepreneurial activities. And then this is much more technical, and this lets me go do a transition in what we're going to do today. Today we are moving to a very simplified set of activities that represent a kind of profile that we as computing systems engineers can develop in order to specialize our professional careers. And this profile is called DevOps. And when we talk about DevOps, one of the aspects that the DevOps activities run is many different techniques in order to deliver different types of resources, including applications, on their virtual environments. And the role of a DevOps specialist would be to be able to prepare these virtualized environments so that applications, systems, etc., can run in some organization or in different types of architectures. And these virtualization techniques are in fact techniques that have been around for all the history of computing, and they are normally taught when we study advanced distributed systems. Here in France, we have a great professor, his name is Sasha Krakowiak, and he has produced a lot of material, open licensed material about many different topics of distributed systems. And one of them is related to many different patterns that you can find in several solutions, commercial solutions, regarding middleware. And certainly that in distributed systems, you talked about middleware. And middleware is a very important component when we want to build distributed applications. And around middleware, we can specialize different aspects of the construction of distributed systems. And Sasha Krakowiak has a book that talks about the different patterns that we can find about middleware. And so I wanted to share this with you because not today, but in the regular course, we are going to start theoretically to study virtualization, and the material that I'm going to use comes from his course. It's not this book, but well, I was his student, so I have access to plenty of material about virtualization, and I'm going to use it in order to introduce these aspects with you. And so this is why I'm sharing his book about middleware. Okay, so as I said, today we're going to do little exercises, first steps, as we always do, baby steps into some activity that can be related to DevOps. So DevOps, in fact, is a set of practices that combine software development and IT operations. Okay, so it's really preparing the execution environment and the work environment that can help people deploy solutions and run them and share them, etc., on for our communities. Okay, so our organizations. So the objective is to shorten the systems development life cycle and provide continuous delivery with high software quality. Okay, so this is about going into the steps of industry, leaving a little bit prototyping and really trying to figure out how do we put systems accessible to users in a real context where you need to make sure that your software has quality, that it runs, that it is accessible to the users, etc., and that through its life cycle, it remains operational all the time. Okay, so DevOps comes from Agile software development, so it's a derivation of it, and many different techniques applied in DevOps come from Agile software development that I suppose that you have studied in your software engineering courses. So you have this infinite cycle of operations where you create, you plan, you monitor, you configure, you release solutions, and then you package some of them, you verify, etc., and like that until the end of times. Okay, and in order to do that, well, there are many different tools that you have to make sure that you're acquainted with and that you can use in order to make sure that this infinite cycle is possible in your context. And today we're going to start with aspects of virtualization. You can see Docker here, that are a part of this practice that DevOps specialists have to implement. And in order to do that, we are going to start with a hands-on. And for this, I have a great pleasure to have invited my colleague. You know his name because we have been using sometimes his GitHub space for some of the exercises that we have done. So he's professor here at University of Lyon. He's specialist in data processing, but particularly he has a lot of experience in DevOps practice. So he has accepted to do the hands-on today with us. And so I'm going to open the floor for him. And we try to organize this as a kind of two voices session. So I hope that it will work and that you will like what we're going to do to have these first steps level. So I'm going to stop sharing my screen, and meanwhile I let you, Javier, open your camera and your mic and so on and so forth.
Okay.
Hi.
Aloha, everyone. Can you hear me?
I'm going to stop my mic.
Okay, Hena,
We
but
do hear
can you
you.
please confirm? Ah, okay,
Yes,
thanks.
we hear you perfectly. They are shy at the beginning, but then they are very chatty. You will see.
Okay. Remember that you also have the button for raising your hand. I mean,
And
which
they do raise
can
hands.
be.
Yes, they do
Yeah,
raise
yeah.
hands. They know how to do that. Yeah.
So one question, Heno. So how do you want to proceed? Do you want me to start the
Yes, I mean,
exercise?
start the,
Do you
the
want to?
exercise,
Mhm.
start the exercise, and then while we are doing the different activities, I will open my mic and will comment
Okay.
what we're doing.
So okay, okay. So um, okay. So the idea is that today we are going to work with Microsoft Azure, you know, the Microsoft Cloud platform, and we are going to continue your experience with the Spark. So the idea is that we are going to create some virtual resources on the cloud so that you can play a little bit with Spark. For this, how can I share with, okay, this is the channel. I prepare a document, a Google document. I'm sharing with you the link. You can go to there. This is the cheat sheet. So with some of the instructions that I'm going to use. Now, what is important you to know is that you need your Microsoft account with the one that is linked to your institutional email, because we
We are
are
going
going
to
to create
spend money.
some, yeah, we are going to spend
Yeah,
credits.
yeah.
Mm-hmm.
So let's be
Okay,
crazy and
so
spend money.
let me so let me share my screen. What is the button for sharing the screen? Share application screen. Entire screen. Share. Can you see my screen?
No.
Nope.
No.
Mm,
I always share my whole desktop because if I only share part of the screen, it doesn't work, at least in my case.
in principle, I said
In
that I
principle,
wanted
it should.
to share everything.
Um,
So can you see something?
we see your face only.
Only my face. Not good. Not good. I don't know. Maybe because this is browser.
And you shouldn't be using Safari. Huh? Prefer Edge or something like that.
I'm using Edge, but I don't know if
Okay.
Edge has the privileges for that.
Maybe you don't have the privileges, but then it can tell you.
Edit. Okay, but I can do Safari should work. Oh. Hmm. 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 Okay, I'm going to connect. I'm going to disconnect and try
And you
to
come back with
reconnect.
Safari.
with Safari, yeah, just to test. So see you in 2 minutes.
While Javier is back, I'm having a look at the questions that you had about the calendar. The activities are scheduled for the 22nd, and then almost, I think, then Friday. So you're back, Javier.
I'm back. And if I share my...
Now we can see.
Holy heaven.
Yeah, but now we can see it.
Now,
Right. We see your browser.
Okay, great. So let me try to remember. Okay. So the idea is that you have to connect to the Microsoft account, but let me see how can we do this. Yeah. So let's start from the beginning. So you already have some experience with the Spark. The idea is that today we are going to create a cluster, a Spark cluster, and for that end, we need to create some components. So you should see the Spark architecture. So basically, there are 3 main components. So there is the notion of the worker node, which is the component which is going to execute the tasks associated to a specific what they call job. You can have several workers on a Spark cluster. Then you have something that it's missing here. Well, the cluster manager, this is called the master component. So the master is going to coordinate the work with all the workers. And then you have some what they call the driver program. And all these components have to be in place in order to execute Spark program. Until now, you have worked locally, so this is hidden for you, but it is there. Rather than starting 3 processes, in fact, when you work locally, you have threads running these processes. Okie dokie. So the idea with the document that I share is the first step is we need to create a virtual machine. Yeah. So the idea here is that the thing is I need to know whether you are on the same page as me. So can you please confirm that you are connected to the Microsoft Azure portal?
Yes.
Even I'm going to get out. So. Okay, let me see. How many of you are already in? Raise your hand, please. Okay, so and you see exactly the same view that I have.
Yes.
Okay, the majority. This is good. Yeah, this is good. Okay, so the first thing is we're going to create a virtual machine. So as I was explaining, so you have in the document you have kind of the tutorial, but to go faster. So if I go to the section where
can I interrupt a second just to
yes.
put a little bit of context? When we work in Colab, we have been seeing that Colab and Google Cloud provides us with a machine where we run our notebooks. Here, instead of that, we are going to configure the machine that we are, or the machines, I don't know if we will have time to create several, then create machines adapted to what we want. Okay, so it's like we're going shopping and we are going to buy several computers that we are going to use in order to build our cluster. So this is the first change with respect to what we have been doing until now.
Mm-hmm. In order to complete that, for instance, what we are going to do is when you use Colab, you are the user. Google's engineers provide infrastructure and they are in charge of configuring everything. Now you are going to put the hat as an engineer, as a cloud engineer, and you are the ones who are going to create the virtual machines and the environment. Okay, so for that, we are going to create the virtual machine. So I'm going to click in this plus button, create an Azure virtual machine. This is going to pop up. Yeah, this form. So the first thing to note is that you can have several subscriptions. I mean, your user can be associated to several subscriptions. In this case, I'm using Genoveva's account. And she has one subscription, which is Azure for students. You should have the same subscription. But in my personal case, I have access to several subscriptions. So this list contains more elements. Now, let's start by creating a resource group. So I'm going to call this Spark Resource Group. And the idea is that a resource group is a container, a logical container, which is helpful for associating all the entities virtual entities that we are going to create. By virtual, I mean the virtual network card, the virtual machine, the virtual hard drive, and so on. So I'm going to call it Spark Resource Group. And this is something new. The name of the machine, I'm going to call it Spark Master. I mean, you can put whatever you want, but in this case, I'm putting this because I have in mind to replicate this cluster. So I'm going to have a master, a worker, and a driver. Okay, so then this will be interesting because as you can see, we can select in which part of the planet we want to deploy the virtual machine. I'm going to select the one that is the first one, the one recommended. So the instance is going to be deployed on the US, but I'm in Europe. So if I want to improve the performance, for instance, the communication between my machine and the virtual machine that I'm communicating with, I should rather select Europe. Now, I don't know, not at this point, but if I choose, for instance, North Europe, this will have an impact on the price of the virtual machine, because it has to do with the cost of energy, the cost of the cost of living in Europe or in different countries. But for simplicity, I'm going to select the US. The rest of the options, I'm going to leave the default options. And then I have to select the image, that is to say the operating system that will contain the virtual machine. In my case, I'm going to use select Ubuntu server, the latest version.
Well, it's in our case. We are going to use Ubuntu servers for working today, right?
Yeah. Yeah.
You said in my case, so okay. In my case means that they can choose something else.
Okay.
Choose Ubuntu.
I mean, they can as long as they select Ubuntu, they're fine. No, but okay. Select the same configuration as me, please. So we are going to use Ubuntu Server 20.04. And then, okay, I already selected the image, meaning that I know which operating system is going to be installed. And as you can see, sorry, I can select the configuration of the machine, which has an impact on the price. So I'm going to select the second one, the one providing 2 virtual CPUs and 8 gigabytes of memory. But at this point, you should see interesting things, because you see how much it costs to run a virtual machine with this specific particular configuration. So as you know, your subscription has some credits, so which means that you can spend, if you want, everything in just one big virtual machine. But if it can last, your credits can last one day, or you can select something which can be more adapted for a specific workload. So in order to improve or optimize your credits, so I'm selecting this one. Then, okay, I have two options. For the authentication with the machine, I'm going to create my own password. So as username, I'm going to type Spark. And then as for the password, you have to respect the restriction that is there. So I'm going to use, I have some auto-generated passwords. So I'm going to put this here, and I'm going to share with you in the document the password. You can use your own, but if you don't want to waste time trying, so you can copy and use the same password as I do. And yeah, by default, the machine will be open to the world in the port 22 for executing secure. This is for the secure shell. Do you have questions until now before I move to the next step?
This is the master node, right, Javier?
Sorry?
Is this the master node?
This is just a virtual machine that, yeah, I will, if we have time, this machine will be the master node. But for the time being, this is just a virtual machine.
Oh, okay.
For the time being, what we're doing is just creating pieces. I mean, just like buying computers.
Mm-hmm.
And then we will connect them to build the cluster.
Okay.
I was prepared just in case. So then we're going to have one. So, but this one is called I have and okay. Questions?
There is a little problem with your mic. Are you typing?
No.
Because we listen to tak, 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 or if you're tapping on your machine.
I'm not tapping right now. Not typing.
Okay, we can survive.
Do you still listen to the?
Yeah, but I know
what I can do is well, let's start with the for other okay. To the next step. So I mean, here is, as you know, saying is like if you go to Office or that, and you said I want this machine with SSD disk or classical HDD. These options have implications not only in price but in the characteristics of the machine. I'm going to see the default values for empty, right? But the idea is you can see a virtual network be created. So I'm going to click on review.
We are listening you, I mean, not clearly. Is this something with your headphones, maybe?
Probably. Wait.
Yeah. Now it's good. I don't know what you did, but it's good.
Nothing. I have no idea. But let me just start the process of creating the virtual machine, and then I will look for other headphones. So this is what the important thing is, to have this green mark validation passed. So I'm going to create a standard D2S virtual machine by Microsoft. We know how much it's going to cost, and the rest you can check the details. And I click on create, and that's it. This will take some time. This is initiating the deployment, and once it ends, I will have the virtual machine. So deployment in progress. So while this is working, let me go and look, replace my headphones. And you should see me. Okie dokie. So in my case, this is done. If I go to resource, yeah, Spark Master. So if I click on home just to see the essentials, then I have the virtual machines section. I click on virtual machines, and I should have one virtual machine. Spark Master, okay, Archive for students, and everything else. And the status is running. So what about you? Please raise your hand if you have your virtual machine running. Great. So congratulations, you just spent some credits by buying a virtual machine. Armando, Carlos, and David, almost there. Okay, David. Luis Felipe is also missing. Okay, but well, the majority is there. Okay, so first step, creating the virtual machine is done. Now we are going to connect to someone. Oh, did someone say? I just put, okay. Now we are going to connect to the virtual machine, like using the terminal. Rather than, look, I don't know what type of machines do you have? Do you have a Mac? Do you use PC? Are you Windows or Linux users? Which version of Linux and this kind of stuff? So rather than using your own personal machines, my decision was to use some of the tools that are provided by Microsoft, which makes transparent for us the fact that everyone has a different type of personal computers. So in order, we are going to connect to the virtual machine using the Azure Cloud Shell. The Azure Cloud Shell, you have access in this button, the Cloud Shell. So if I click here, boom, this opens. Yeah, you will see, first you will see this. The shell, in order to work, requires some storage space. So I'm going to click on create storage, and as every time you create something, behind the scenes, Microsoft is spending computational resources and storage and brand memory. So this has a cost, and because of this, some of these resources are free, some of them have to be are paid. So, but the idea is that with your accounts, with your credits, for you, this is free. And for instance, this is a classical bash shell.
There are questions,
And the storage,
I think that someone has a question.
Yes, me. I have a question.
Yes, do.
Mm-hmm.
Do ask.
It's just that it appears in the command, well, in the prompt, in the Cloud Shell, sorry.
Mm-hmm.
Bash or PowerShell? Which would we
Mm-hmm.
click?
Bash.
Bash. Okay. Thank you.
Mm-hmm. Indeed, you can use, if for instance, if you are a person who is familiar with Microsoft technologies, maybe you prefer to use PowerShell. If you have experience working with Unix-like environments, this is my case, I use Bash, but because this is something similar to what I have in my Mac. So, but yeah, that's a good question. So what I was doing. Okay, so here I have the shell. So you can use any terminal. You can use any terminal as long as they support SSH. Indeed. But I mean, the problem is people using Windows. Not all versions are already configured for that. But indeed, you can use any terminal who can connect to SSH. Then what we are going to do in order to connect, yeah. So what we need to know is the public IP of the machine. So in the list of virtual machines, like my SparkMaster virtual machine, if I move to the right, I have the public IP. I'm going to copy this IP. And I'm going to tap SSH, the name of the user, in my case, Spark, also your case, I suppose, at the IP address of the virtual machine. And then there is a connection between the shell, which is another virtual machine, but this is already provided by Microsoft behind the scenes. This machine is trying to connect to my virtual machine, my own IP. I said, yes, I want to connect. Then it asked me for the password. I copy paste the password. And that's it. I'm connected to the instance. So even you can see if I do this, if I type clear, okay, see, the Spark user is connected to the machine called Spark Master. Are you still with me? Yes, two persons, but please raise your hand. I prefer to see hands because like that I can see how many of you are still. Okie dokie, so the majority. Great. Okay, so we are connected to the virtual machine. Great. So the second part that's done. Now remember that we have an empty virtual machine. So there is besides having Ubuntu and some pre-installed tools, there is nothing else. So what we're going to do next is to install Spark. We're going to start by copy pasting these commands. So the first one basically is wget is I want to retrieve Spark binary files. So you see this is the binary zipped file. Well, that's a tar rather. Then I'm going to untar the file.
This is similar as what we did in order to install Spark on Colab.
These are the same steps.
Yeah.
So this is done, and finally, yeah, CD for entering the. Now, if you are curious how I obtained the URL that is in the here in the document in the Google Doc, you can go to the Spark Apache Spark website. Then, when you click on download, you can select the release that you want. For instance, 3.2.1, and I select also the Hadoop the 3.3. And then when I click on download this version, it sends me to the to all the servers containing this release. So this is the one I use. This is the one that you are using for collecting for retrieving the binary. Okay. So that's it. We have installed Spark, but the Spark requires Java. Right now there is no Java in the machine, so I'm going to install Java, and I'm going to also to install this is Java, the default version. This installs Java 11. If I remember well. Yep. So if I move to my diagram, in fact, here I should add something like Spark with the version and the other version. We have Java 11, and I suppose that's it. Yeah, and there is Python 3 already installed. But this is something that you have to do. The difference with the Colab virtual environments is that there are tons and tons of libraries that were already pre-configured for you. Done. Yes, it. Okay, so finally, this is, we are not going to use this right now, but this is important. This is important so that Spark knows what version of Python it has to use. In this case, it is Python 3, because if I type Python, there is no Python in the Ubuntu in the virtual machine. But if I type Python 3, there is the interpreter there. So this variable environmental variable is for specifying which Python interpreter Spark has to use. And yeah, we are almost done. Finally, we need to open two ports in the virtual machine, the port 4040 and the port 8080. Now, for doing this, you have to move to the interface, to the web portal. In that case, so you have the virtual machines, you have your Spark master machine. I click there. I obtain all the information concerning this virtual machine. Then in settings, you have the option of networking. And in networking, you can add some rules for allowing communications from the external world. The first one is the 8080, which by default is already in the form. So I click on add. This triggers the creation of the rule, security rule. So now I have communication from port 8080 allowed. I'm going to do exactly the same thing for port 4040. You have to modify 2 places. That's it. Okay, great. So again, we have we installed things and ports opened, ports opened 4040 88. So you see, this is all the configuration of the machine. Okay, so now we have Spark, and we are going to test it. So I'm going to issue this command. Basically, this computes pi. And this is one of the examples that is.
And until here, note that we are just doing the same as we did in Collab. We will have one machine running the program. Okay. Later on, we will see the cluster version.
Yeah, indeed. We are starting bottom up. So one machine, Spark is installed, and we run locally. And here you have the pi is 3.14, etc., etc., etc. So before continuing, is everybody still with me? Great. Okay, because now I'm going to do something more interesting. I mean, we're going to repeat exactly the same, but have a look at this. What you need to do is you need the public IP.
Just give me a second. Alexander, Armando, Carlos, Fernando, Francisco, and Garrett, are you fine? Jose Antonio, the others?
Yes, thank you, doctor.
Okay, okay. Do not hesitate to say stop. Thank you.
Yeah, please. Otherwise, I have no way of knowing whether you are still with me, sleeping, doing some errands at OXXO, watching Netflix.
They can do both.
Kind of. Okay. That's not a good idea. I mean, because this is, you have to follow. Okay. So now look at what we are going to do. I'm going to copy again the public IP address of the machine. And I'm going to say I want to see access port 4040. there is nothing to show. Yeah, that this is normal because in fact, this address is the web interface of a Spark context. Remember that the Spark context is in fact the one controlling the resources of a Spark application. So let me show you this, what I'm going to do. This example computes pi, but it does the calculation so fast that the program ends quite fast again. What I'm going to do is I'm going to add 2 zeros for this is for the precision that I want for the pi number, because I want that the Spark takes some time. So I'm going to copy this, I'm going to execute, and while executing, I'm going to move to the other tab, and I'm going to access again the same address, but in the port 4040. And this is something that I believe that you haven't seen so far. Here you can see, in fact, how Spark is organizing and scheduling the activities in the local cluster. So you see, if you want, for those who are in the database domain, I mean, this is
Remember
kind of the execution
the
plan.
DAG that we have been talking about theoretically? There's the DAG.
Mm-hmm.
That's the execution plan.
Mm-hmm. So, and this, well, this is, well, I mean, you usually just see these, like these prints and so on. But in fact, what it's interesting is this, is the fact that there is the notion of task. For computing pi, I suppose this is using 10,000 tasks, and 3 of them are running in parallel. We have a lot of information how the cluster is distributing the resources. We have information about what they call the executors. I don't think this is going to, yeah, because the assumption is that at some point when you are working in a cluster, some of the nodes can fail. What else? Yeah, and that's it, because the program stopped. And because the program stopped, so I no longer have the interface. So I'm going to repeat the procedure.
It terminated.
Yeah.
It didn't stop.
It terminated.
Terminates.
Yeah.
Stop is failure.
Like Terminator, indeed.
Yeah.
Mm-hmm. Indeed. That's true. Mm-hmm. Okay, once again. So I have the timeline, the stages. So basically, all the internal, everything that it's happening inside Spark, you have it in this web interface. And even if you click here, for instance, I mean, since this is only computing pi, there is no access to disk. This is not so detailed, but yeah, you can see that you have processes. Each process is associated to a task, and you have the status of the task, whether it is success or fail. If there is a failure, then Spark has to schedule the re-execution of that task, and all of this. Yeah. So, any questions till now? I mean, you should have questions.
Yes. Then, what's the difference between a job and a task? So, what I understood or what I think is that a job is composed of several tasks, and each task or each group of tasks is assigned to a working node.
That's true, indeed. At some point if you read the Spark documentation, you will have an answer to that. But usually, when you are working in a cluster, what you send to the cluster is a job, and the idea is that a job can be decomposed on several tasks and these tasks are assigned to the nodes that will do the work. So in the diagram, you can see that every worker contains an executor, and an executor is in charge of executing one or many tasks. So a job is decomposed of several tasks, and it's the role of the master of scheduling all the tasks composing the job into whatever resources are available.
Okay,
In
and
this
then
case, with the workers.
yes, and then I wanted to ask just a
Please
follow-up
go.
question. Can you hear me?
Yes, I can hear you.
Okay, yeah. So if I'm not wrong, the driver program, it's within the master node, right?
The driver program is, everything is running on the same machine. This is what, for instance, if you see my slide, my diagram, there is only one virtual machine, and everything is running.
Yes, but I think that his question
in this
is
machine.
regarding the threads. What is thread and what is the general master process?
What is thread? Well, I suppose that this has to do with this part. Spark Sub, it's a program that sends the job to the. In this case, the Spark Submit is going to act as kind of, it's not the driver program, but the Spark Submit is going to send the program which will act as driver program. That program is this one, the Spark Pile. Now, this is a Java class which is inside a jar. And in fact, what Spark submits to the cluster, to the local cluster that you have here, is the jar, and specifies which class contains the main class, which will contains also the Spark context.
In fact, what you have is a process that acts as the one that contains the job. And this process contains your Spark context, and within the Spark context, you have, in this case, the jar that with your main. And now the cluster manager knows that this process exists. It is the cluster manager that breaks this program into pieces that are sent to the threads or to the workers when we have separate machines. But you see, this driver program is kind of external to the master. It just communicates to the master saying that it is asking to the master to execute the program contained in the context. But you have two separated processes.
I suppose, I believe if I move to the second part, I mean to create if I create the
yes,
cluster
if we
with
create
them,
the
maybe,
cluster exactly
they will have enough elements
for explaining this. So give us a second, and then we move to the cluster version, and then we can have the comparison.
Because I mean the thing is that indeed this is not easy to see, because the fact that this is local means that everything is simulated. Yeah, everything is simulated. And once the program ends or finished, the resources are free.
From what we have been seeing,
like,
it's the same case in Collab, and I think that the questions come from there, that we have never seen a real cluster, and we have never seen the different pieces running independently.
Indeed. And this is because of a technical restriction with Colab. So the simplest thing to do is to run the Spark in local mode, just for testing.
So let's,
But because I mean, configure it in.
So let's move to the cluster, and then we come back to your question.
Okay.
Right?
So. Indeed. So let's create the Spark cluster. Let me see. This is still computing. I'm going to stop it. Stop it. Stop. Okay, it's busy. Okay, we lost it. Poor guy. Okay, right now. So I'm back. What happened is that I had to close the shell and open a new one. So again, I need to connect for creating the cluster. I need to connect to the machine. So I'm going to reconnect SSH. Then my user Spark at the again, I need the password. Chan chan. Okie dokie. I'm connected again to the same machine. I'm going to cd to the Spark folder, and I'm exactly like before. Yeah. Okay, for the creating the cluster, there are already some scripts with the in the release that helps you create a cluster, a simple cluster. For instance, with this script, the one that it's inside has been, you can use this one to start a master. Tac. So I executed everything. The result is in a file. So if I cat that into my console, I can see that the master is running on a specific URL. But let's see that on the port 8080. For that, again, you need the public IP address of the machine, and then you go with the browser to that IP plus the port 8080, and then this is the master. I have the interface of the master. Even you can see what is the internal URL of my virtual machine in Azure in the east of US. This is internal. I mean, if I copy and paste this URL in the browser, it's not gonna work. So this is just the master. If you prefer, this is not a good example, but what is the cluster? Okay, the cluster manager. This is the master. There are no workers. So the second step is to add some worker. For the time being, we are doing everything in the same machine. So, and this is the interesting part. I'm going to start a worker, but I have to give as parameter the URL of the Spark of the master. So you need to replace this with the URL that you see in the web app. For example, I'm going to copy this. I'm going to put it here. But I mean, this only makes sense for me. You cannot connect to my machine because ports are closed. So I'm going to copy this. Yep, clear.
Are you following what he is copying?
Okay, this worked, which if I refresh the web app, look, now I have one worker. I have, my cluster has 2 cores, 2 CPUs, virtual CPUs, and my cluster has 6.0 gigabytes of RAM memory. Okay, we are at this point. Remember, the important thing is that this part, which is highlighted in yellow, you have to replace it with the URL to your virtual machine.
Yes, insist on the colors because at least me, I do not see when you move the mouse.
Okay. So basically, so what we just did is inside the virtual machine. So now we have 2 let me change color. So we have a master now inside the virtual machine, and we have a worker, and they are connected. Well, that's what we did, and this is why we have this cluster. So please, do you have questions? I hope you have questions. And I mean, either that or we can run the example. I mean, this is exactly the same. Yeah, let's do that before questions. So we are going to reproduce the same example as before, but no, the difference is that rather than saying use local, what I'm going to specify is I'm going to specify the URL to my cluster, to my master. And even while it does that, I can refresh the web interface of the cluster and see there is a running application called Spark Pi, which is the Java application that I just submitted. And again, we can see how many resources that this is using. And for instance, the number of cores granted is 2. My cluster only has 2 cores, so everything is allocated to this program. And it finished. Yeah, it is completed. So just to finish this diagram, I should add another box. This is the driver. Yep, which connects to the master and so on. But in the same way, what I can do is I'm going to use this. Look, this can help you understand. I'm going to connect using PySpark to the cluster. I didn't test this, so I don't know if this is the good instruction. PySpark. PySpark not found. Yep, I remember. This is because okay. I need to wait. Okay. It should work. Okay, and this is the interesting part. those who are familiar with Python, you know that Python is a interpreted language. So if you type just Python, you have you enter the interpreted environment. But look at this. This environment is connected to the Spark cluster. So every instruction I use using Spark context will send all the operations to the cluster. Even if I go to the interface, we can see that there is a running application, which is the PySpark shell, which is running and which is using the 2 cores of my cluster. So I can do something as simple as reading a text file, which exists in the machine, the README. For instance, this is an example. And this is similar to what you usually do in Colab. So, okay, I just read the file using Python. And then I'm going to count the number of lines in the file. But remember, this is going to happen in the cluster. So this is why you saw, I don't know if you saw that. Let me move this up. So again, count. Now it happens very fast. Yeah.
Yeah, because README is very small.
The thing is that everything is now in that, and everything is in cache now.
Yes.
Yeah, I have to stop this.
Can you go back to your figure, please? First of all, we did create several virtual machines, right?
No, we have created only one virtual machine.
One virtual machine with 2 cores, and the cores are simulating the fact that we have at least 2 workers, right?
No, is in fact this is different. Usually these blue boxes, when you work with the local version of Spark, there are no process. There is only one process and a lot of threads.
Yeah, and now
In this version, we're still in one virtual machine, but the blue boxes are processes. The next step will be
to create several virtual machines.
A new virtual machine. Yeah, and then move the blue box.
Yes, really move the workers
Yeah,
to the second virtual machine and leave the master on the first virtual machine with the driver.
In fact, we can do that. I mean, we can create a second virtual machine, virtual machine 2.
Yeah, that would be great.
Only for a worker.
And then leave the master.
This is, I mean, we already have this. We already
yes,
have
but
one
again,
worker in virtual machine 1.
Yes, but again, since everything is grabbed in one virtual machine, that we still have the problem of not seeing clearly what is worker and what is.
No,
I'm sure that they do see.
We can do that. I mean, the thing is that the process. They should speak.
They should speak by themselves. I know.
Yeah. So, but before continuing, because I mean, the
yes,
idea is
I will let you
to do
continue,
that. But
and
before
then we'll
continue,
open the.
And so, do I continue?
Yes, do. Do.
Okay.
Continue.
Okay, so let's create another virtual machine. Again, you know the principle. It's exactly the same as we did before. Some subscription Azure for students. I'm not going to create a new resource group because I already have one called Spark Resource Group. The name of the machine is going to be Spark Worker. Ubuntu Server 20, that's the one I want.
Excuse me, should we create
is there a
this
question?
virtual machine
What does
as well?
the port? Yes.
Okay, thank you.
Because what we are going to do is we are going to move. In fact, we are going to create a second virtual machine, and then in this new virtual machine, we are going to start a worker, and then we will configure the cluster to use that worker. So you need to create the second virtual machine.
And there is another question on the chat.
There was a question. What does the port? Yeah. The port 4040 does. The port 4040 is for having access to the web interface of the application of the, in the diagram, this one, the driver program. If you remember at the beginning, the first thing that we did was run Spark locally, and then we saw the execution plan. The execution plan is per application for that specific application. And this is useful when working on just one local environment. When you are like us creating a cluster, then you have the web interface of port 8080, which is not that nice, but gives you the overall picture of the resources of the cluster. So these are two different web interfaces. Is that clear, David? David Fernando Rosas Chavez. Okay. Okay, so I was creating my second virtual machine. I'm going to use the same password. Spark for the user. Okay, virtual machine. For the rest, it's the same. Disks, everything is fine. In principle, if I create review plus create, this should work. Validation failed. For some reason, this happens. But if I click a second time, it seems that yeah, it works. I mean, this is quite weird. But okay, validation passed. So create. So this is creating a second virtual machine. So it's like if I ask someone, please go and buy another server. Not now. Deployment in progress. Spark master. Yep. I have to wait for the second virtual machine. In the meantime, I need to reinstall Spark and everything because I mean this is going to be a new virtual machine, an empty virtual machine. So yeah, but I need the IP. Okay.
So important thing that you have to make sure that you can picture in your minds is the setting where we work completely locally with threads. The second setting where we work with several processes working on the same virtual machine. And the third setting, which we use two virtual machines and we deploy a worker on the virtual machine, the master in a different machine, and they communicate. Okay, so these are the three different settings that you have to picture in your minds and understand how the interaction among the processes happens when we are in these three different settings.
Mm-hmm. Still creating.
Yes, Mauricio.
Yes, I have a question. What is the Spark resource group? What is a resource group? I don't understand the concept.
That's what I said at the beginning. A resource group, you will see that it's a container, but of resources. It's a way of simply saying all these resources, virtual machine, and network cards and everything. Look, in my particular case, I have 3 resource groups, and probably you also have 3 resource groups. All the resources associated with the Spark resource group, in fact, are my virtual machine, Spark Master, the IP. The IP address is also a resource. The network card is a resource. The hard drive is a resource. So the fact of grouping everything in this notion of resource allow me to better manage the resources. For instance, rather than going one by one for deleting them, which I'm going to do at some point, I can click here and say, I want to delete the group. And this is kind of delete everything that it's inside. It's like having a folder.
Oh, okay. Yes.
But groups are more powerful than folders because you can associate security rules, policy rules, properties. I mean, this is, as you can analyze, for instance, all the resources of the, this is something we haven't seen so far. For instance, for my resource group, I can see that how much credit I have spent on that group and see the aggregated view of all the resources. I mean, not here, cost alerts, and this is something I should configure. Insights, for instance. Let's see if this is, I don't remember if insights or metrics. Select a scope. For instance, okay, I want this one, resource type. No, this is virtual machine in the US. Okay, apply. Filter split. Okay, now this is more complex that I have to, I will try to show you this, but at the end, not now. But that's the idea of a group, of a resource group. So at this point, I should have the second, yes, I have the worker, it's running, and I have the IP. So now that I have this, I'm going to repeat what we did previously. So I'm going to connect to the new machine, to the worker. I need again the password.
Everything that we are used to see as one package, including the network, is fragmented in the cloud. So we are really building a computing environment with connection, with virtual machine, with everything with main, and the virtual machine with main memory, etc. So everything necessary to have an execution environment, and all this is grouped as a resource group. And so you can see the consumption, you can see details on how you are consuming in a very fine grain or in an aggregated manner. And this is why eventually, if you are a DevOps, you have to have control of all these and then make decisions according to your consumption, whether to group differently, whether to change properties, etc. Because you are managing your resources and you are also have the limits of the credit. Okay, so you are responsible of not going beyond your credit, but providing all the necessary resources to run the different applications for which you are preparing the environment.
Okay, just to check whether you are still following, what I'm doing is just installing Spark again, following this again. So I have a new Ubuntu machine, so I collect the release Spark release 3.2.1. I installed Java. Because I mean, this is something that you probably didn't see, but the two virtual machines have to contain exactly the same configuration, the same Python version, the same Spark version, the same Git version, and everything has to be the same. So this is just managing the environment. This is a thing to do. So okay, so this is done. I configure this in principle. So we have two virtual machines with exactly the same configuration. Now, what I'm going to do at this point, what I have is this. I have two virtual machines. And what I'm going to do is I'm going to create a worker and connect this worker to the master. Okay, for creating a worker to start a work process worker. So I need, yep, remember the parameter that requires this script is the address of the master. But before I do anything else, have a look at my screen. At this point, my cluster has 2 cores and 6 gigabytes of total memory. I'm going to kill this. Okay. Voila. Yeah, so no running applications, 2 applications that are already completed. Now, when I add the worker, the resources are going to increase. Here, I'm here. So start worker, talk. So in principle, now I have 4 cores and more RAM to my cluster, which means that now I can work with more, I can do, I don't know, more computations or deal with more big, I mean, not for big data, but I suppose that you understand the principle. I'm adding machines with only 8 gigabytes of RAM, but if I add machines with 100 gigabytes of RAM, 20 of them. So now we have this. So we have 2 workers in the list. Both of them are alive. Each of them contributes with exactly the same number of cores and the same memory size. Now, I'm going to execute again the PySpark, this one, just to have something so that we can see something. Okay, this is working. Yeah. So I refresh. I have one running application, which is the Spark application. The application is using 4 cores. since I didn't specify the maximum number of cores, the application uses all the resources of the machine. So imagine if all of you, we can, all your virtual machines, we can use them to create a big cluster. So you are, how many students do we have? 18 persons are connected. Let's suppose that we use 18 virtual machines and we add 18 workers. Okay. Now, the idea of having something like this is that everyone can share the resources. But if there are no policies about how to distribute the resources of a cluster, someone can arrive and use the 100% of the resources and block the rest of you, which is kind of not fair, depending on the scenario. And this is what happens in the high performance computing centers. There are kind of policies or quotas saying, yeah, the students of this kind of course, because they are experimenting, they can use a maximum of 10% of the resources of the cluster. Or when we are in a hurry or we need to do compute some simulation stuff, where we can allow applications to use up to 80% of the resources, or the total of the resources. So in this case, the 4 cores are used, but I believe that not all the memory RAM is used, but I'm not sure about that. Well, now the resources are free because the application ended. So, questions, please.
We have like maximum 5 minutes to wrap up because they eventually have other classes. But of course, feel free to ask questions.
Now they are working.
Huh. There is a question on the chat.
Okay. I don't know. I don't think so, because the idea is that as long as you have resources and you can, for instance, one of the companies that had some years ago, one of the biggest Spark cluster was Spotify, for computing the recommendation algorithm for, for computing recommendations, and they used to have the biggest cluster in the world, and it was big. Google had the equivalent running, and so in principle there is no limit. But this is, since you are doing computer science, you should know that this is a false promise, because there is always a limit because of the physical machine.
Yeah, in fact, there are,
memory is limited, but virtually,
potentially you can have any amount of workers that you have, depending on your credit card, of course, because this costs money. But then when we study parallel computing, in fact, what they teach you when you address these issues is that there is a limit on the number of workers that you can have with respect to the performance, the increase of performance that you achieve. And at some point, if you have more workers than the limit, then your performance goes down. So the key challenge is to determine how many workers with how much memory, etc., you can use, such that your program runs in the best conditions possible with the best performance possible. That's for the running aspect. Otherwise, well, it's like how many machines can you buy? As much as you can afford.
And even now, for instance, if you can see my diagram, basically, for instance, I have a lot of workers. We can assume that we know that, Black Friday, or in Mexico is El Buen Fin. we know that a lot of people is going to buy articles on the weekend. So you saw that because we have access to the cloud, we can create several machines and install, for instance, use them as workers. So we can use them only for the workload on the weekend, because we know that a lot of people are going to use them. And then suddenly we don't need it anymore, so we can delete them like that, just like that. Because everything is virtual, you just need to configure them. But the nice thing of this is that you can create on demand. As long as you can pay, you can have and configure whatever your specific needs are. Now, Geno, I suppose I should show them how to delete the resources before they leave.
Yeah, there's a question by Alexander, and then, yes, please show them how to delete the resources, and so that we can wrap up.
Mm-hmm.
We will continue in the next lab with other activities. So, but please, Alexander,
okay.
there's a question.
The Spark worker. The Spark worker is not associated with ports 8080 and 44. Yeah. The 8080 is with the master, and 4040 is with the Spark context that I didn't show you. But I mean, you use it during when working with Colab, but you didn't see the details. So no, you don't have to open the ports. So we have finished this. So
this is because it's a master slave architecture. So the only entry point is by the master, never by from the workers.
All right.
So there is you see, there is no point that you allow access, external access.
Understood. Thank you very much.
You're welcome.
Okay, so for deleting this, otherwise you will consume all your credits. So you can go to resource groups, and then, for instance, select the Spark resource group. And well, if you click in the resource, you have the option delete resource group. I click there and I follow the instructions and I delete the resource. This will remove the 2 virtual machines and all the resources associated to the virtual machine. I mean, the public IP, the security, the network security group, the network interface, the disk, everything will be deleted. And then you can reproduce the same, you can continue like that and delete, for instance, the network watcher. Of course, we didn't have time, but one of the ideas when you work with the cloud is that you have to monitor how your resources are being used. Because now it's not only about computing the complexity of an algorithm, but also the impact in terms of computations and energy consumption and cost, economical cost. So, and at some point, this will delete all the resources, and that's it. You will have nothing. I mean, if you click at some point, if you click on all resources, this will be an empty list. But of course, this will take some time, as you saw the first time.
So should we delete
because now you're using yes. I mean, my advice is do that unless you want to experiment by yourself.
No, because we need to do. We need to use them for the next lab. Then afterwards you can do whatever you want.
Yeah, because Henna is right. If you consume all your resources now, for the next time, you will not have.
We will go on vacation.
The question, for instance, yeah.
Oh, that's great. We're almost there.
And if you put your
No, I
Yeah.
don't want to put my credit
But
card.
the thing
Once
is,
we have the experience with
exactly. You
Javier.
don't try that. Yeah. Don't do that. I mean, when I have to, I use my own credit card, but I know how to use these things. But even like that, you should have to be very careful, very careful.
Okay then. So I won't delete it now.
Yeah, please do so that we can spare resources for next labs. Yes, do delete.
I mean, the question is quite weird because remember, if the machines are running, they will consume resources, meaning
Even
that you
if
have
you're
to
not
pay for them.
using them.
Even if you are not using them, exactly. So delete them
Yes, do delete
or
them.
stop them.
Yeah.
Yeah, because everything has a price. I mean, even if you are charging your telephone, that watts, number of kilowatts, have a cost. So be clever. Yeah, so be clever.
Yeah, I mean, for the time being, delete, then eventually once we will be sure that we will not need more assured resources, then you can experiment. But for now,
Yeah, in my case, I don't have, everything is deleted. Okay, so I'm stopping, I'm going to stop the...
okay. Do you have more questions, guys and girls? So if there are no further questions for his course, if there is someone wanting to ask something to me afterwards, do, but if there are no more questions for Javier, I think that we can give an applause. Thank you very much for being with us. And then we will send you questions eventually. We have.
Thank you. I want to applause too, but I don't see the... I can raise my hand, but that's it.
Yes. Thank you very much, Javier.
You're welcome. Okay, I'm going to copy this because otherwise I cannot clap.
Okay.
Clap, clap.
Clap, clap. Yeah, clap, clap. Like in dance studios, we all clap to all of us for our work today. Just a comment before you leave. There were questions about the calendar of activities. I answered in a general announcement on Slack. You only have to hand in 2 exercises. I specified on Slack which ones, and they are due to the 22nd of April. They are just worth 5 points. So they are very simple things to do. And this is the only thing that you have to do, because the other ones that appear as deadline are the summation of the different things that you have been doing during the month.
Doctor, so then we only need to upload both of those homeworks, and then the next thing will be the TikTok, right? Or on the Medium.
The next thing, we will have a very short one for these DevOps, but very, very short, because we're touching the end of the semester, and the next one will be the final. Now, I wanted to say something about the final in both labs and course. Start thinking about what you can plan, and you can interact with me so that I can help you if you want to plan what you're going to do for the very final.
Okay, so then is it a single? I read that I think we need to do a medium post.
You need to do a medium. There is I don't remember who is who, but in one of the courses you need to to write a medium and a TikTok or a video.
Okay, perfect.
So if you start thinking about these issues and that you want to interact, please do. But in the meantime, only two very short, 5 points only activities for the 22nd of April.
Okay.
Yes. Anyway, if you have specific questions about what you have to do contact me on Slack. I have been answering questions to other colleagues, so please do not hesitate. Okay, so if there are no further questions, today we have a long session. Thank you very much for your participation, and I see you on Friday. See you, bye-bye.
Thank you, doctor. Have a nice day.
Same to you, bye-bye.
Doctor, can I ask a specific question about the activity? The
Yes, of
first,
course. Please do.
yeah.
What is your question? I can confuse you further.
No problem. Yes, well, on the activity that's called first steps into data flow based programming, I asked you some questions and you answered them via Slack, but I
Yes.
still have a question
No
because
problem.
yeah, because on the first point that says state the principle of each control and data flow based programming model. Yeah,
For parallel programming.
yes, yes. Based on what I researched, because I still had some questions on specifically on data flow based. So what I did was I researched about that and I found that, well, I think you said that it was wrong. I found that data flow was based on declarative programming, but on your answer it's
Not necessarily. I didn't say that it's wrong. I just say that data flow programming model is not necessarily declarative. For example, you can have in SQL, it is a data flow based programming model and it is declarative.
yes.
But for example, if you use Python, we are PySpark, for example, we are using a data flow based model, but Python is functional. It's not declarative.
Oh yeah, you're right.
You see, or Java, for example.
Okay, but then I don't know if, correct me if I'm wrong, but I found that for control flow, in the control flow model, what you're actually doing is describing, like giving a sequence of commands, like an algorithm of how to solve a
Exactly.
problem. And
Yes.
on data flow, you're like that part of telling how the problem is solved is implicit, and what you are actually doing is
Yes.
simply describing the solution or what you want.
The flow, yes,
Yes.
because what you have is the operators are already there. You do not program them; they
Yes.
are already there. But what you define is the sequence of operators that you apply on top of data. So you have data that come, that are fetched, and then something happens, and then a new result comes out of the process, and etc. And so you exhibit the different I/O that you produce every time you apply an operator.
Oh,
But
okay.
the I/O is explicit. So you know, for example, in Spark, you know the structure of the RDD. So you have an initial RDD, If you
Yes.
filter, for example, you have a
Another one.
new
A new one.
resulting RGT,
A new
and you
RGB.
know the type and everything, and then etc. until you finish.
Okay.
Whereas in MapReduce, you don't. I mean, it's parameters, but what you focus on is on the implementation of the
On the how.
map and
Right.
reduce functions. Yeah, right.
Oh, okay. Doctor, and by, I don't know if any that I can use for flow on Spark, because I was looking for that on Google, and I found a lot of like Google data flow, like not exactly on the model, but rather on a product made by Google called Dataflow.
Yes, but in fact, if you are looking for references for data flow model, it's more academic papers that you should look for, like parallel processing with data flow. But I mean, I can even send you references on that if you feel that you need
Yes.
them.
Well, if you could, I would really much appreciate, because, well, as I researched more about Hadoop and Spark, I was really interested
Yes,
on like the whole like distributed
right.
processing and big data management and processing, and I would really enjoy reading about that.
Yes, very good. So I will send you, there are articles comparing, in fact, what is better, because now Spark has become very popular and it's a product, but there were papers showing two things: what is best for what, and also what are the implications on expressivity. Can I program the same using a control flow model and a data flow model? That's a big question. Because if I cannot, then I have to identify which are the algorithms that I can implement with one or the other model. So that's one thing. And the other thing is the performance implications.
Oh, okay. Yes. And lastly, my last question, doctor, sorry for asking a lot of questions, is like on the last point of the to-dos activities, it says compare the implicit and explicit strategies adopted by Hadoop and Spark for dealing with data persistence, caching, sharing, and shuffling, and the implication of these strategies in the design and execution of programs.
Yes, in the Hadoop version, the shuffle and the sorting activity is delegated to the engine. So in fact, we know that it exists, but we cannot explicitly configure it from the program. In fact, we can configure it, but by tuning the engine. But once the engine has been tuned, your programs run accordingly, and the shuffling and the sorting tasks are hidden or for the program, they are externalized. Whereas in the case of Spark, um, you can decide at what for every operation that you perform on your program, whether the results can stay in main memory, can go to the cache, or they can go to disk, and whether different processes can share the results that someone produces. And from the program, you as a programmer can explicitly say what you can do and what you want to do. And this is all about performance. If you do not cache, for example, data, then and you systematically put them in the HDFS as we do in Hadoop, then you penalize performance if other processes are using the partial results produced by, for example, by the map. And if you maintain them in main memory or in cache and you allow other processes to share it, you reduce overhead. And this
Oh, okay.
lets your program run better. The thing is that this implies that you, programmer, must be aware of what you want and at which point do you want this to happen. So it's a hard decision-making problem that if you can do it, then you will improve the performance of your program. But technically, it's difficult.
Oh, I see.
You see?
Yes. Thank you so much, Doctor.
You're welcome. So I will not forget to send the references, right?
Yes, thank you, Doctor. Have a nice day. Bye.
Same to you. Bye-bye. Yes, Alexander,
Thank you, Doctor. Excuse me, I have a couple of questions too regarding the
please.
activities to give this week. For Friday, for the 22nd, there are two activities that we have to submit. That say, for example, there's the programming data processing with MapReduce, which was done in a team and it's on Google Doc. And there's
But
also
that one you don't have to. There are only two. Just let me see the general announcement. So there are two. There's the HO2, First Steps into Data Flow-Based Programming. That's for the lab. And the other one is Data Processing with Spark. That is for the regular course. The other ones you have already done.
yes, it's true. However, in that case, well, so in my team's case for that programming data, there's
Yeah.
some things missing, so we have to complete that.
You have to complete, exactly.
Yes. So my question was, with this activity, another one called data processing with MapReduce, the one about the Kahoot game and the presentation, because those are in the cloud in
Those are
Drive.
the-
I want to ask if we
And
should send them as well, or
no. That you already did, and I know what you did, and I can have access to them. I have the links on them. So
okay,
there you do not have anything to do. They are done.
I see. But should we also submit them to Blackboard or with just
No, nothing.
no? Okay. Okay, very well then.
Very well. Good.
Thank you very much, Doctor.
You're welcome, Alexander.
Have a nice day.
Same to you. Bye bye.
Bye bye.